Okay, so we're recording now. And for you guys, 220, 230. For question 13. So we're going to start and then we'll transition to the questions in the 20s. So question 13. Question 13 is kind of a tricky question. It's not meant to be tricky, but there's added information in there you don't need in order to solve this problem. And so that might be why the question was asked. But for 13, it says the physicians, or first of all, is this the same thing that you guys have? Just want to make sure number 13 is the same.
Yes.
Okay, thank you. Because sometimes I pull up an older one, but I don't think I did that. So, and then someone asked about rounding. Yeah, you're going to follow the same rounding rules that you've followed first semester, second semester. And that includes not rounding your basic conversions, like the first 5 questions. You never round when you're just doing basic unit conversions. All right. So 13 it says the physician orders dexamethasodium phosphate, 5 milligrams intramuscular every 12 hours with a patient weighing 127 pounds. Strength in the vial is 4 milligrams per milliliter. How many milliliters will you administer? The patient's weight has no variant on this question. The only time you would need to worry about that is if it said that you're supposed to administer 5 milligrams per kilogram, then you would need to know the patient's weight, and then you could convert milligrams to milliliters. So I do think that that's probably the thing. You've been trained at this point to convert the patient's weight from pounds to kilograms, which is a good thing. And then just kind of tying this back to, I believe it was Nathan's question, applying conversion rules. When you go from pounds to kilograms, you're going between 2 different units. In that situation, you would round to the nearest tenth. Because you're going from 1 unit of measurement to another unit of measurement. So you're going from the American standard, or the American standard, to the metric system. So you would do a round to the nearest tenth in that situation, if it's number greater than 1. But for 13, we don't need to convert pounds to kilograms unless you just want to do it for funsies. You would just take the patient's order of 5 divided by 4, and then that's how many milliliters you would administer. So just in case the key is wrong, which happens, 5 divided by 4 is 1.25, and you would round that to 1.3. Okay. Yeah. You're always going to round your medications to the nearest tenth. The only time you're not going to round is if you are doing basic inter-unit conversion. So this would not technically be a basic inter-unit conversion. And then the other rationale is you probably could give them 1.25 milliliters if the syringe has that as an indication. But if your syringe only goes to the tenths, then you have to round. And that's what I think the rationale is behind that. So for just about everything, excluding your basic inter-unit conversions, meaning metric to metric, you're going to round to the nearest tenth for a number greater than 1. And if it was a number less than 1, like let's say the answer was 0.25, then you would leave that answer alone. You'd round to the nearest hundredth in that instance. See, I was assuming that the question was actually because of the patient's weight. It was actually a rounding question. So I'm glad that we saw that. So yeah, so when you do the calculation, you get 1.25. You will round that to 1.3 as your final answer for this question. Anytime you're going and calculating meds, you do round it. You're asking the loaded question of why. I don't know why. That's just what it is. I'm assuming, you're welcome. And I'm assuming the main reason why is just because that's probably what you have available to administer. You may not have a syringe that goes down to the to the 100th place. But if you know, like I know, that you do have syringes that go down that low, so kind of negates that question. But okay. All right, 21 through 25. All right, so 21, you saw this last semester, and I apologize, the camera likes to jump. So 21, this basically says you have a certain medication ordered, the Pfizer pen, 350,000 units. You're to administer using the strongest concentration, and then calculate how many milliliters. Again, this is a pretty straightforward question that I think you know in the past, and hopefully you got this from previous reviews. You ignore the milliliters diluent added. That's just an extra information that you don't need to know in order to solve this problem. All you need to know is what is the strongest concentration, 1 million units per milliliter. And then you're going to take your 350,000 divided by 1 million, and you're going to get 0.35 milliliters, and that is your answer. So you do not round that because that number is less than 1. Okay, sorry. So that was 21. All right, so 22, 23, and 24 are all relatively new for this semester for you guys. And what's nice is that all three of these actually help you. Well, 22 and 23 actually help you out with the heparin protocol, which is also new to you. But essentially, we're going to be doing the heparin protocol. This is a step in the heparin protocol, number 22. 23 is doing the same math, but we're using insulin instead of heparin. Okay. So let's do 22. So 22 says the order is 0.45% normal saline, 1,000 milliliters IV with heparin, 25,000 units to infuse at 1,000 units per hour. Calculate the flow rate in milliliters per hour. Now, the thing that's tricky about this is it just seems like it's all backwards. But when you get to the protocol, you'll see why we have questions like this. So there's a couple of different ways to kind of go about doing this. I'm just going to jump in and show you how I would do it. And then you can, if you have another way, as long as you're getting the same answer, then you're doing it right. Just have a little bit of confidence as far as that's concerned. So I'm going to start off with, because I'm going from milliliters per hour and because I'm converting one flow rate, units per hour, to another flow rate, milliliters per hour, I'm going to start with my, so this is question 22. I'm going to start with the 1,000 units per hour. And the reason I'm doing this to you guys is I'm just trying to show you like what my process looks like. I could start with whatever I really feel like starting with. I just chose to start this because I know I want hours in the denominator. And I know that units per hour is a similar rate of volume over time, just like milliliters per hour, just like drops per minute. And so I'm just trying to keep things that are similar in an organized way. Now, we know we don't want units, right? We want milliliters. Well, we have some information that can help us get there because we have a 0.45% normal saline, 1,000 milliliter or 1 liter IV. And in that IV is 25,000 units of heparin. So I've already set up the problem. I just need to put in the right information. So 25,000 and then 1,000. Okay. So basically what I've done here is I just, I took what was in my bag, my solution, my 0.45% normal saline, and I'm using that information to convert units per hour to milliliters per hour. And so I'm going to take 1,000 times 1,000. And I'm going to divide by 25,000. And I'm going to get 40 milliliters per hour. alternatively, yeah, Sharon, you wrote exactly what I wrote. Yep. Say we did it exactly the same way. You just flip flop these two things, which is fine. Like I said, you can start as long as you get the right answer, you're doing it right. And another little shortcut, you can cancel out these zeros. And so it's 1,000 divided by 25. It's a little bit easier to plug into your little 10 key calculator and not hit too many zeros if you feel comfortable doing that. If you don't feel comfortable doing that, just make sure that you're getting the right answers, and you'll practice that as you're going through. So how might I change this question? Well, this question could be changed by changing the quantity of the saline solution, okay, the quantity of the units contained within of heparin in the saline solution, and then also what the units per hour flow rate is. So you can edit all those things. And then, like what Sharon said, you know, she did 1,000 over 25,000 times 1,000. Basically, you just did this. You know, you set this up, you started with milliliters per units times the units per hour. We got the same, as long as we get the same answer, you're setting it up correctly. Yep. So I'm going to do 23, which I would set up the exact same way, but I'm going to do it the way Sharon did it. Okay. So 23 says 0.9% sodium chloride, 500 milliliters, IV with Humulin R regular U100 insulin, 500 units, and it's infusing at 10 units per hour. So what I'm looking for flow rate in milliliters per hour. So what I'm going to do is I'm going to start off with, I know I need milliliters in the numerator. So I'm going to start off by taking the 500 milliliters over the 500 units of insulin. And then I'm going to multiply by the infusion rate of 10 units per hour. And you'll notice that for this question, you don't really need to do any math because the 500s cancel out and you're left with 10 milliliters per hour. Just make sure you cross out your units if you're not in the habit of doing that. But this is just the alternative. I could have also done what I said in the first thing where I start with units per hour and then eliminate units. Either way works. So long as you're getting the right answer, you're doing it right. I always say we're in Pittsburgh, right? So you go, if you're going through a tunnel to go in one direction and you're coming back through that tunnel, we're going through the same tunnel, but we're going to be maybe approaching it from a different way. So I'm either going into the city or going out of the city, right? I'm going to Kennywood, I'm going to a Pirates game, you know, whatever the case may be, okay? Going to the airport, going back to the city, okay. $24, again, is just using, this is not the same as 22 and 23. This is just kind of recalling something you may have seen last semester. I can't remember. But basically what we're doing is we're taking the our liter of solution and we're infusing it at 50 milliliters per hour. And I just want to know, when am I going to need to, or when's that infusion going to run out if it just ran continuously? I know just because, and I'm sure you would say the same thing, the infusion runs out when the alarm goes off, right? It tells you that it's time to change, because I do believe that there is going to be an alarm associated with that. So sorry, my chair keeps sliding down. I'm trying to adjust it so I can keep it from sinking on me, but anyways. Okay, so with this, there's a couple different ways to do this, and I think most of you probably get this one right. You're just going to take, for 24, you're going to take the 1,000 milliliters divided by 50, and that'll give you, because that's 50 milliliters, that's how many hours. And then I believe you get 20 hours out of that. Okay, so that part is probably self-explanatory, but the trick is, if it started Monday at 8 a.m., what time will it finish? So the trick here is, you know that 24 hours will be Tuesday at 8 a.m., right? So let's just say 24 hours would equal Tuesday at 8 a.m. So what would 20 hours be? That would just be 4 hours less, right? So that's going to be Tuesday at 4 a.m. Okay. So I know, silly question. Sometimes I think it's just a matter of like just trying to rationalize like how we get to these times. But if you remember just remember your clock, and, you know, as a nurse, I think you end up working 12-hour shifts. So you'll get used to that, you know, okay, what is our, you know, that's a 10 to 10, 10 a.m. to 10 p.m. or whatever the case may be. Or maybe you work the twilight hours, you know, 7 to 7, or, you know, whatever the times may be, 7 a.m. to, or 7 p.m. to 7 a.m. You know, you'll get better at doing these types of time conversions. They just, sometimes they ask this question, but I don't even know if it's on your test. It's just an extra practice. So, all right. The last question here is the doozy, which is the heparin protocol. Okay. Now, I know you haven't seen this before, other than if you've watched my reviews, then you've seen what this looks like. But other than that, you haven't really seen this, because you usually don't get it in class or anything like that. But so when we talk about the protocol is essentially what's written out here. So what would have been better is if I had like kind of put this into like a, like, you know, kind of blocked it out. That way you could see, okay, these are the things when they talk about a heparin protocol, these are the things to kind of follow. Okay. When we look at the protocol, there's a couple things in here that we don't need to worry about. We don't need to worry about the CBC. We don't need to worry about the GAIA-X stool. We don't need to worry about the neurochecks. Those are all important in a clinical setting, but for the math part of these things, we don't need to worry about those things. Those would likely be standardized within the whatever it's called, the would be standardized in the hospital setting that you're working in. Okay, so there's a couple of things. Each question will always start off with the same basic thing. It says to bolus a patient with heparin 80 units per kilogram body weight, and then to start a drip at 18 units per kilogram per hour. The reason it says that is because that's actually step 10 of the protocol. Bolus with 80 units per kilogram, start the drip at 18 units per kilogram per hour. So this is kind of at the top. This is just redundant information, but it just tells you what to do. Now, patient's weight will be listed in pounds. Sometimes it'll be listed in kilograms, but it'll typically be listed in pounds. The thing that I can change, or that has been changed on the actual test, is the patient's weight. So patient's weight could be 210, 215. So, okay. So Jared asked a really good question about, will there be an even number for the weight? Meaning like when you convert pounds to kilograms, maybe. If it's not, round to the nearest 10th. Okay. So if you need to, when you convert the patient's weight in pounds to kilograms, go ahead and round to the nearest 10th. And then do the rest of the calculations. And I'll give you an example of that after we go through the first step here, or the first run through with the original. Okay. So these are the protocol steps. When you come down, these are actually the questions that you'll see on the test. On your actual test, you're only going to see 2 of these. Okay. It'll either be A and B, or it'll be the C part 1, C part 2. Okay. So you usually won't get both questions. I put those both on there for you for additional practice. Okay, so that way you can practice this, because what you do in A is the same thing you do in part 1 here, and what you do in B is the same thing you do in C2 here. They're both the same thing, so it's just extra practice. So let's just go through this so we can kind of see what this looks like, especially if you haven't already gone through this, or if you just want to kind of see it live. So the first thing it says is to calculate the number of milliliters to administer for the bolus. So the first thing I need to know is, what do I do with the bolus? Well, in the protocol, it says to bolus with 80 units per kilogram. So let's do that. First thing I need to do is I need to convert the patient's weight in pounds to kilograms. So patient weighs, this is 25 heparin. In this scenario, the patient weighs 110 pounds, divide by 2.2, and that will give me, is it 55? Or 50, sorry. Will be 50 kilograms. Okay. Now it says to bolus the patient with 80 units per kilogram. We eliminate kilograms. 50 times 80 gives me 4,000 units. So if the question had asked how many units to administer the patient, we'd be done. But the question says, calculate the number of milliliters to administer for the bolus. So I need to know how to convert units to milliliters. So this is where the protocol comes in. And every time we do this, it's always the same. Okay. So in the bullet or in the protocol, step 2 says heparin 25,000 units and 250 milliliters half normal saline. So that is what is, in their IV. Then the second thing it says is bolus dosage strength of 1,000 units per milliliter. We're going to use the bolus dosage strength to calculate the bolus dose. And we're going to use the units or the heparin units in 250 milliliters half normal saline to calculate the flow rate when we get to that point. So that's what we're going to use here with the 4,000 units is we don't want units, we want milliliters. We're going to divide by 1,000 to give us 4 milliliters to administer for our bolus. So for a 110-pound patient, the initial bolus would be 4 milliliters.
Sorry, I have a question. So 1 milliliter equals 1,000 units. In this problem, that wouldn't necessarily ever change, right?
As long as we're doing a heparin protocol and following the same protocol and we're calculating a bolus dose, correct. It would always be whatever you get in units, divide by 1,000.
Okay, thank you.
You're welcome. Yeah, so if you do a Google search for heparin protocol, this is what shows up. Okay, that's where I initially got it. And then in the math tests or the math textbooks for drug calculations, they also have this listed as the heparin protocol. So if you're ever looking for the heparin protocol, you can just do a search for it. And you can also find other questions similar to that. Okay, so this was part A of the questions. So we just found the answer. Oops. Say part A, just in case you're trying to follow along with that. All right, so part B, now we're going to get into calculating a flow rate. So part B says, calculate the infusion rate in milliliters per hour for the heparin IV drip. So what in the world does that mean? Well, if we go back to the original question, which is at the very top of the question, but also step 10, it says the bolus with 80 units per kilogram, then you're going to put them on a drip at 18 units per kilogram per hour. Okay. So I'm going to take that 18 units per kilogram per hour. I'm going to apply it. We're talking about the same patient, right? So it's a 50 kilogram patient times the 18 units kilogram hour. We eliminate kilograms and we get 900 units per hour. So far in these two scenarios, the only thing that's really going to change is the patient's weight. Okay. Then, as it says here, we want to know the infusion rate in milliliters per hour, not units per hour. We're going to go back to step 2 of the protocol where we look at what do we have them already hooked up to, what's in the IV. It's 25,000 units of heparin in 250 milliliters, half normal saline. So I want to get rid of units and I want milliliters. Now, I'm not going to use the 1/1000 here because we're not talking about bolus anymore, right? We only do bolus strength with bolus calculations. We're doing the IV infusion rate and we're going to use the IV bag for that. Okay. So this is 25,000 units. And then this is 250 ml. So this number is actually, I'll just write it in red. This number, if you do the division, is actually 1/100. Okay. So if you're ever looking for like a shortcut as far as, you know, what would this be? If you ever get stuck, when you're calculating the bolus, divide by 1,000. When you're calculating the infusion rate, divide by 100. And then you'll get 9 milliliters per hour. Now, inevitably, when you have a patient's weight that could round to when you round that to the nearest 10th, you're likely going to get an answer that also gets rounded to the nearest 10th. Just keep that in mind that your final answer is the one that needs to be rounded to the nearest 10th when you get to that point. All right, so C part 1 and C part 2 are continuations of the protocol. C part 1 says, after 6 hours, the patient has an APTT of 43 seconds. So there's this boxed area here that has all these different APTT times listed. 35, less than 35 seconds, the range of 36 to 44, 45 to 75, 76 to 90, and then greater than 90 seconds. So depending on what it tells you is the APTT, then you're just going to kind of follow the protocol here. So when it says here, like hold heparin for 1 hour and decrease the rate by 3 units per kilogram per hour, if it asked you to calculate a new bolus, well, there is no new bolus to do for an APTT greater than 90. So you wouldn't do that. If the APTT was 50 seconds, it says continue the current rate. So you wouldn't change anything. Okay. But our thing says 43 seconds. 43 seconds tells us to do 2 things. It tells us to rebolus with 40 units per kilogram. And then it says to increase the rate by 2 units per kilogram per hour. So we're going to administer another bolus dose, but we're going to do half of what we originally did. And then we're going to increase the rate in order to accommodate for their lack of appropriate clotting. Or I should say they're clotting too easily, and we're trying to affect that. Okay, so C part 1 says to calculate the number of milliliters to prepare, and what they're asking for is they're asking for the new bolus dose. I know it's not 100% crystal clear, but I want you to know what it is that they're asking for. Okay, so we're going to take same patient weight, and the new bolus is now 40 units per kilogram. Okay, so notice that I'm setting this up essentially the same way. It's just that now I'm using the new information, and the new information came from the protocol. So basically, they're just testing that you can read through this protocol that's not supposed to be confusing. It's just, but it is confusing until you've looked at it a couple times. That gives us 2,000 units because we've eliminated kilograms. We don't want units. We want milliliters. We're doing bolus. So we're going to use the same bolus dose strength of 1 milliliter per 1,000 units. Cancel out units. And I'm left with 2 milliliters. Now notice that's exactly half of the initial bolus. Hold your thought, because I haven't done that second thing about like adding the 2. So you got that right, but the 40 and the 20 have nothing to do with each other. So let me work through part 2 and just make sure that we got the same answer. So see, part 2 says calculate the new infusion rate. So the new infusion rate says to increase by 2 units per kilogram per hour. So what was my original? 18, right? So 18 plus 2, and I think this is what Sharon was mentioning, is 20. So patient weight times the new infusion of 20 units. Okay. And I'm going to get 1,000 units per hour. Does this look familiar? Heparin is infusing at 1,000 units per hour. Convert that to milliliters per hour, same as question 22. Then we're going to use that same 250 ml over the 25,000 units. And if you remember, I told you that's the same thing as 1 over 100. And that'll give me 10 milliliters per hour. Now, the thing to be careful about, and this is something that I did when I initially was learning how to do these heparin protocols, is, this was half of this, but you don't want to add 2 to this. So because I initially said, 11 milliliters per hour, because I just add 2. It's 2 units, and then we still have to do the proper conversions. It's only going to work that way if this was a 1-to-1 relationship, and it's not. It's 1 to 100, and so that does not work. So don't do what I did. Okay, just make sure you work that out. So again, the only thing that really can change is patient's weight. The other thing that can change is, what the APTT is. If I had did, let's say you got a test, and the test said after 6 hours, the patient has an APTT of 30 seconds, then you would just follow the protocol and then answer the 2 questions for the new bolus and the new infusion rate. You don't even need to know what the previous bolus or the previous infusion rate is. You just need to follow the directions as far as that's concerned. So let me give you an alternative scenario that will kind of go hand in hand with what I just said. So let's say I have a patient, and what I'm going to do is I'm going to give you just as a whole new heparin protocol question. Okay, so this is completely new and semi off the cuff. Okay, let's say I have a patient that's they weigh 197 pounds. That way we can try the rounding thing. They have, after 6 hours, so they've already been on a protocol, their APTT is 28 seconds. Okay, just better write seconds. All right, so my question is to calculate the new bolus and then calculate the new infusion rate in milliliters per hour. Okay, so patient's 197 pounds. Step 1, convert pounds to kilograms. 197 divided by 2.2 will give me 89.5454545454 repeating. Okay, I'm going to recommend that you just go ahead and round that to the nearest tenth. So 5, 4, 5, 4, 5, 4 repeating. I'm just going to recommend that you round that to 89.5. Okay. Because if I did the test and I wrote this out and I'm writing the key, that's how I did it. I should also say that I'm not the one who grades your test. If I was the one who graded your test, I would pay attention to how you set this up and then kind of grade you based off of your competence of being able to kind of set this up. Even if you chose not to round, I would say it's wrong if you just left it at 89. You definitely need to round to the nearest 10th because you've been told to do that for so much. So anyways, so 89.5 kilograms. So I'm going to calculate the new bolus based off of that 89.5 kilograms. My protocol says, because the APTT is 28 seconds, that's less than 35, I'm going to rebolus with 80 units and increase the rate by 4. Yeah, so someone asked about rounding and you answered that perfectly. Yeah, so when we're rounding to the nearest 10th, the number greater, you look at the number to the right. So I looked at the 4. 4 is less than 5. I don't round up. If it were 89.55, 56, 57, 58, 59, I'm going to round up to the 89.5. If you have 89.999999, it's 90. Okay, so don't get hung up on that. So anyways, it says to rebolus with 80 units per kilogram per hour. So I'm just going to write 80 units. I'm sorry, not per kilogram, per hour, but 80 units per kilogram. So I'm going to take 80 times 89.5, and I'm going to get 7,160 units. I don't want units. I want milliliters because that's what I asked you for. And I'm going to use the same thing that I used for the other calculating the other bolus dosage strengths. Is I'm going to use the bolus dosage strength as indicated in step 2 of the protocol, which told me it was 1 milliliter, 1,000 units. I'm going to eliminate units. And then when I do this, I'm going to get, 7.16?
Yep.
7.16 milliliters. And then again, I'm going to go ahead and I'm going to say, just because this is what we're doing, and is to round that to the 7.2 milliliters. Okay. So I do realize, and I'm recognizing, and I'm telling you, this is okay, that you're rounding twice in this problem. Even if you had waited to round, like, let's just say I left that, so I'm going to go back to my original 197 divided by 2.2. I'm just going to leave it in the calculator. Okay. Then I'm going to multiply by 80, then divide by 1,000. I will say it does change the answer up a little bit. Oh, no, it doesn't. I still get 7.16. So I would still round that answer to 7.2. So whether you rounded it or not, you came up with the same answer. Okay. So if you want to wait and round at the very end, that's fine. Again, if I was the one grading that, I'd be like paying attention to that, and I'd give it to you either way, but I'm not the one that's grading it, and I'm not the one that's able to give you that information. So me saying that doesn't help you out at all. And then you can always ask your instructor if they prefer that you round the weight to the nearest 10th first before proceeding with the rest of the calculation. 89.5 kilograms. So now we're going to do part 2 of the question, which is, what is the new milliliters per hour? Looking at the protocol, it says to increase the rate by 4 units per kilogram per hour. Now, we didn't do anything right for this patient. We weren't there for the initial configurations, but we just look at the protocol. The initial was 18 plus 4, we get 22 units per kilogram. Okay. So what's 89.5 times 22? You're going to get 1969 units per hour. Sorry, I forgot the per hour here. We don't want units per hour. We want milliliters per hour. And we know from the previous looking at step 2, 25,000 units in 250 milliliters, half normal saline. So 250 milliliters, 25,000 units. And remember, that's the same thing as 1 over 100. Okay. So 1969 divided by 100. Yeah. And I'm going to get 19.69 milliliters per hour. And then what am I going to do? I'm going to round that to the nearest tenth, 19.7 milliliters per hour. Now, in an actual clinical situation, you may not be able to set the infusion pump to 19.7. It might only go to, you might have to set up to 20. So I just want you to keep in mind that what you would do clinically may differ than what we're doing like on pen and paper math wise. There's probably ranges, there's probably grids, and then ultimately you're going to make corrections based off of the APTT, right? Because you're trying to make sure A, you don't want your patient prematurely clotting, and B, you don't want your patient to bleed out either, right? So you're going to make adjustments, and you're going to do little adjustments, not these big, great adjustments, if that's the case. But obviously, if your APTT is less than 28 seconds, that likely means that they're what? They're clotting still too prematurely, and we want to prevent that so they don't have, you know, stroke or throw clots or things like that. I think you understand that process just fine. So. All right, so that's what I had for you guys today. I think I answered all of your questions, but if you have any other questions, please let me know.
Thank you.
Yeah, you're welcome.
Is Thursday session the same time or is it 5?
Yeah, so there's two sessions on Tuesday and 2 on Thursday. So I'm with you guys 1:15 today and Thursday, and then 5 o'clock today and Thursday. So both times are available.
Okay, thanks.
You're welcome. You're welcome.